something that allows us that kind of capability is certainly all of the injection molding presses that we have at MTD, save for one, is our Sodicks. So most all of them include this V-line injection unit, right? So this is a picture of one of our molding cells. They're all 20-ton molding machines, and we have a V-line injection unit. So here we can see this area is where the injection unit exists on the machine. Here's the hopper, so they're all hopper fed. We dry in a hopper here and then feed into a system of barrels that differ from a conventional inline reciprocating screw injection unit. So to kind of help you guys understand what these look like or how they behave, this is what our typical injection unit kind of looks like, right? So our hopper would sit in this area here, and we'd feed our polymer resin pellets down into this first heated barrel area. So this heated barrel area contains a screw, not any different or much different than a typical injection molding screw, where we have our certain regions, our melting and our mixing regions, our metering zones, those kinds of things, except for a big difference here is that this screw doesn't actually reciprocate. So there's no check ring to seal off against or anything like that. It doesn't move back and forth like an inline unit does. Instead, it will just it acts more like an extruder than it does an injection molding unit, where it will melt, mix, and convey the material through the system, and then only move forward just a little bit to seal off after it's done conveying. So it will convey down into this next region, right? This region down here is another heated barrel zone that contains a reservoir and a plunger. Okay, and that looks something like this. Here's kind of a transparent view of what I'm talking about. So this extruding screw will convey, melt, mix the material through this junction area. Sometimes we call this a touch cap. And then after that phase has finished, the screw will advance forward to seal off here, so that this acts as our check ring instead of actually having a check valve or a shutoff valve. It extrudes the material down into a reservoir where this plunger will advance forward to shoot the shot into our mold. So a big advantage to this, and why I point this technology out, is because there's no check ring, there's no longer any minute backflow, right? Because as a reciprocating screw would advance forward, that check ring takes a little bit of travel time to seal off. And during that travel time, you can have certain levels of backflow with your molten material. Well, when you get down to the scale that we're at, where we need microscopes to see our part, or the part that we're producing might be the part that we're producing might be 0.01% of our overall shot. Small variations from shot to shot because of backflow over the check valve can become really problematic. And things can become really inconsistent very quickly. So for this system to exist and operate the way that it does helps us with our repeatability a tremendous amount.